In exercise 11H, which is called the reverse chain rule, we need to think about these sorts of questions in terms of the advanced course and the extension course. So if you were asked in the advanced course to find the integral of this first one here, for example, it probably wouldn't be a standalone question. It would probably occur as part 2 of a question, and obviously preceding that would be a part 1 of a question, and in part 1 of a question you would be asked to differentiate an expression. Now, the idea is you differentiate an expression. This is either the answer you get or very close to the answer you get. So if it is the answer you get to your differentiation, if it's you've differentiated something here, d dx of blah, if it gave you 12x, x squared plus 1 to the 5, if that's what it gave you, then the integral of your answer, or the answer to 1, is back to whatever you were asked to differentiate, obviously plus a constant. So that is this type of question in the advanced course. In the extension course, this sort of question would be probably presented to you with the restriction that you have to use the substitution rule. So it's a typical extension 1 question, however the instruction will say use it by integrate it by substitution. Now, we haven't learnt the substitution rule. When we get to substitution, though, it should be fairly easy to see why and how the substitution rule works. Okay, but for now, we're going to do it in the context of the advanced course, and it really will rely on you being able to see the pattern that develops. So it says here, this exercise relies on your ability to observe patterns. I've been talking a lot about patterns in the last few videos, and make connections between differentiating and integrating. So let's find dy dx. Let's differentiate this one. So dy dx is bring the 6 to the front of your x squared plus 1 to the power. Now subtract 1 from your power and multiply by the derivative of the inside, which is 2x. I'm just going to write that as 2x times 6 bracket x squared plus 1 to the 5. Okay, what are our observations? I mean, you never ask this, but you know how I've been saying when you do a question, we're going to focus on this see, think, wonder. Well, even part of the way through the question, it's a good idea to stop and have a look at, what you've got, see what you've got, think about it and wonder. So here, what do you see? Well, it's fairly obvious that the bracket stays the same between the function and its derivative. The bracket has stayed the same. The power of the bracket has come down by 1. But really the most important thing to see is that there is now a term outside the bracket, which is the derivative of inside the bracket. What that does then, it allows me then to wonder or think about the integral of all of this, say 12x, x squared plus 1 to the 5th. Now, when I see that, it may not be that obvious because 12x isn't the derivative of what's inside the bracket. But you have to have this ability to say, oh, well, I can see it's 12x, but what do I know 12x is? 12x is what I want, the 2x. I would prefer it to be 2x outside the bracket, and that would be times by 6, and really that sits very nicely with the rest of what I have, because this now becomes the power that was brought to the front. So my observation was that the derivative of inside appears outside after differentiating. And okay, so if I was asked, let's have a look at these examples. I'm asked to find the integral of 12x, x squared plus 1 to the 5th. That's just the one we've done. And we've talked about how the 12x isn't exactly what I want, but I can see I could write it as 6 times 2x, x squared plus 1 to the 5th. And I can see now that I do have the integral, the derivative of inside the bracket on the outside, and hence the integral of this becomes x squared plus 1 to the power 6 plus a constant. And I guess I also should have said can't integrate a product using any other sort of rule. Can't integrate a product. And that's why we rarely see this sort of question as a standalone question in advanced. It usually does follow part 1 of a question that has asked you to differentiate. Let's have a look at the next one. The integral of 24x, x squared plus 1 to the power 5. Well, considering that inside the bracket is an x squared plus 1, ideally I'd like outside a 2x, which I can make here. So if I took that as the integral 2x, then what I have to have left over is a 12 bracket x squared plus 1 to the 5 dx. Now let's have a think about it. I have to start to think about what would have happened here, and I could see that when I integrate that I've got to add 1 to the index. That becomes a 6, divide by that new index. Or thinking about, I suppose I could go and divide by 6, and what's left over is a 2. I've still got a 2 left over. So now I want not just my original bracket to the 6th power, but I want 2 times it plus a constant. And the good thing about this is you can always differentiate them and see if you get that expression. The next one I think you can see is we will have the integral, yes, of 2x times 2, which is not quite enough for what we want. And so, but if we go through that same process where we know that we've taken care of the derivative inside because we've got this term, then we can think about integrating that, adding 1 to the index. And if I divide all of that by my new index 6, you can see that the 2 cancels into the 6 and leaves us with a 3. And of course we've got to add a constant. What has happened here is we haven't got quite enough. So I'm going to set it up having what I need to have in there, which is a 2x term. And now to do that, I can only introduce a factor of 1. So you can see I've chosen to write 1 as 2 on 2. Now we could take out our minus 1/2 outside the integral and write it as 2x, x squared plus 1 to the power of 5. And now I can see that I have the integral of what's inside the bracket. So I'm going to add 1 to my index, and I've got minus a half. Add 1 to the index, and divide by the new index, which is going to actually give me negative 1 on 12 x squared plus 1 to the 6th. Now, like I said, it's going to be very unusual in the advanced course to even get this sort of question as a standalone, and in the extension course, if you're asked for that integral, then, like I said, the instruction is usually to use the substitution rule. So don't worry too much about this, but on the other hand, they are worth doing because it's just another presentation of a question where recognizing what you've got is really important. What they've presented to you, if you don't see the pattern in it or recognize the features, then you certainly will have a lot of trouble answering these questions. Okay, with these, I'm just going to differentiate this function. The reason I've separated them from the previous one is because you can clearly now see we're moving into fractional indices. So another way to write that is 5 minus x squared to the half. When we differentiate it, what do we get? So just differentiating, bring the half to the front, you get a negative a half, that's going to make a fraction, and multiply by your negative 2x. Happily the 2's cancel out, you get a negative x over, this will go into your denominator, and you may or may not reintroduce the square root sign, you just might leave it as 5 minus x squared to the half. What have been my observations? I would observe here in this answer that you've got a negative, but I think more importantly, you've got x in both the numerator and the denominator. So if you were asked for the integral of that, immediately you'd go, this is a real problem. This is a problem. Because we don't normally integrate x in the numerator and denominator. We don't normally have that situation. Our instruction previously has been, you've got to do something about it. Well, in this case, as you can see here, we end up being asked to integrate this exact expression. But I'm going to run out of time in doing that example, and I want to do these two together. So I'm just going to stop the video now.